Hi friends, how are you all? Hope you all are doing good. I am 𝗂𝗽𝗍𝗺 BiPC from TTWREIS 𝗬𝗏𝗧. Friends, today I came here to explain you all about the general principle of metallurgy. In this general principle of metallurgy, we are going to study about metals, friends. So in our day-to-day life, we use different kinds of metals in various purposes. If you see your surroundings, majority of the things are made up of metals only, my dear friends. We all are using lot of metals in our day-to-day life. Why not, friends? I am only using lot of metals in my day-to-day life. So let us check what are they, friends. So friends, if you see this ring was made up of gold. Gold is a metal, my dear friends. And if you see this chain was made up of platinum. Platinum is also made up of metal only, my dear friends. And if you see this bracelet was made up of silver, my dear friends. Silver is also a metal, my dear friends. Look, friends, I am only carrying all these three types of metals on my body, friends. So once you think yourself, once you question yourself, how much of metals we all are using in your day-to-day life and in our relevant life. We all are using huge quantity of metals in our everyday, my dear friends. And if you see your surroundings, you will find majority of the things, right? So human beings are depending upon the metals, my dear friends. Human beings are interlinked with the metals. We all are using lot of metal. So if you see our surroundings, we will find 3 or 4 different kinds of metals, my dear friends. So let us check what are they. If you see my surroundings is what, friend? My nearby things, right? So if you see my nearby things, this bench was made up of metal, right? So if you see this water bottle was made up of metal, and the windows, the doors, all these are made up of metals only, my dear friends. And if you see here, the cars are made up of metal, the railway tracks are made up of metal, and the electric poles are made up of metals, and the cooking vessels, bangles, all these are made up of metals only, my dear friends. So we are all using huge quantity of metals in our day-to-day life and in our relevant life. So if you see in the periodic table contains 118 elements so far, right? In that 118 elements, most of the elements, my dear friends, majority of the elements, they belongs to metals only. So in that 118 elements, 80% of metals we can find in the periodic table, my dear friends. So S block, P block, D block, F block, all these 4 blocks contain 80% of metals, my dear friends. All we are using in metals only. So now we are going to study more about metals, my dear friends. So basically metal exists in 2 states, free state and combined state. So what do you mean by free state, my dear friends? Free state is nothing but a element which does not react with another element to form any new substances, or else a element which does not combine with another element to form any new substances is called as free state, my dear friends. So everywhere we all are using huge quantity of metals in my day-to-day life. So if you see, friends, gold is the best example of free state. Why? Because gold is we find in pure state only, my dear friends. So if you dig the earth, you will find gold directly. Why? Because gold is free state. So here the free state metals all are in pure state only, my dear friends. They are stable metals. They are less reactive, my dear friends. They does not react with the atmospheric gases. They does not react with other elements or other metal. So we find the free state metals in the pure state only, in the pure form only, my dear friends. And if you see another example, silver and platinum, these both are also free state only, my dear friends. If you want silver, you directly dig the earth, you will find silver, my dear friend. If you want platinum, you directly dig the earth, you will find platinum, my dear friends. Why? Because they all are mineral, they all are in free state only. That's the reason we can find directly. Then what about iron, friends? If you want iron, if you dig the earth, do you find the iron? Okay, leave about the iron, my dear friends. If you want aluminium, pure aluminium, if you dig the earth, do you find the pure aluminium, friends? No, friends, never. We won't get the pure iron and pure aluminium, my dear friends. Why? Because they are not in free state. They are in the combined state. My dear friends. Not only iron and aluminium, my dear friends. Most of the metals, majority of the metals, they all are in the combined state only. So what is combined state, friends? Come, friends, let's study about the combined state. Combined state is nothing but a element which always reacts with another element to form a new substance, or else we can say it as a element which always combines with another element to form a new substance. It is called as combined state, my dear friends. And if you see the examples, majority of the metals, they all belongs to metals, so combined state only. So friends, the combined state metals all are more reactive. It means what, friends? It always reacts with the atmospheric gases, it always reacts with the elements, and it always reacts with the other elements, my dear friends. And basically it becomes impure, my dear friends. Suppose this is a mineral, friend. This is a metal. This metal always combines with the impurities. What are impurities, friends? Sand particles, soil, rocky substances, clay particles, all these are considered considered as impurities. So this metal, you always want to combine with the sand particles, it always want to combine with the rocky substances, clay particles and the dust particles. Finally it becomes impure, my dear friends, right? It becomes impure. So we want pure iron, right? We want pure iron to make the fans, to make the windows, but we are not getting the pure iron, my dear friends. We are getting the impure iron. So what do? We need to extract the pure metal from these impure substances. We need to extract the pure metal from these impure substances. After extracting the pure metal, with this pure metal you can do whatever you want. If you want to make the chairs, you can make the chairs. If you want to make the benches, you can make the benches. Everyone, whatever you want to make, you can make in the free state, my dear friends. This is called extraction of pure metal from the impure substances is called metallurgy, my dear friend. So let us see a live activity. Let us see a live activity. Friends, every day I used to go for running in my school playground in the every morning. So one fine day morning, while I was running in my school playground, suppose friend, this is the school playground. Let us assume that this is the school playground, my dear friends. So while I was running in the playground, this 2 rupees coin, was fallen in the playground, my dear friends. So it might be any country, my dear friends. If you go to the America, if you go to the Canada, if any country if you go, all the country has this respective coins, right? So all the coins are made up of metals only. All those coins are also made up of metals only, my dear friends. So this is Indian coin. It was 2 rupees coin, my dear friends. This 2 rupees coin was fallen from my upper pocket. While I was running, this coin was fallen from my upper pocket, my dear friend. So it was fallen on the ground. It was fallen on the ground, my dear friend. So do I pick the coins? So after 5 days, friends, I found the same coin in the same playground. So do I pick the coin and put into my pocket? So if you are in my place, friends, what do? You pick the coin and directly put into my pocket? No, friends, we won't. Why? Because we find the metals like this. Why? Because this coin has lot of impurities, it has lot of dust particles, it has lot of clay particles, my dear friends. Why? Because this coin stayed 5 days in the soil, right? So on the coin, all the dust particles used to form, all the impurities used to fall, my dear friends. So it becomes impure. Like this only we find most of the metals. Like this only we find majority of the metals in the combined state only. They are combined. So this is inside there was metal, right? So this metal always combines with the impurities like such as sand particles, dust particles, rocky substances and all the clay particles, my dear friend. So what we do here? Is we need to extract the pure metal, right? So what we do here is I am removing all the rocky substances, friend. You can see here, right, all the rock substances. So I am removing the rocky substances and I am removing the clay particles and I am removing all the sand particles, my dear friends, and I am cleaning the dust particle. And finally I was washing it under the water. My dear friend. So what we get here? We got the pure metal. My dear friend. It was shining, right? This is the pure metal. Before that we saw it is in combined state, right? It was in impure condition. So we won't use this kind of metal in our day-to-day life, my dear friends, because on this coin it has lot of impurities and a lot of sand particles, clay particles, right? So we won't use this kind of metal. This is the pure metal, my dear friends. So the extraction of pure metal from these impurities is called as metallurgy. This is called as metallurgy, my dear friends. So before we are going to study about metallurgy in brief, let's study about the 3 terms of metallurgy, my dear friends. So there are 3 terms of metallurgy. So what are they, friends? Mineral. First term of the metallurgy is called as mineral, my dear friends. Mineral is nothing but it is a naturally occurred chemical compound and it was rocky substances. What, friend? It was naturally occurred. It was not man-made, my dear friends. It was not man-made. Why I am saying it was not man-made? If you see this, friend, if you see this pen has a creator, right? This pen has a creator. Someone created this pen. And if you see this watch, this watch has a creator, my dear friends. This watch has a creator. And if you see the bulb has an inventor, right? So everything has a creator and inventor. Then who created the mineral, friends? Then who created the minerals? Who invented the mineral, friends? Do J.Sh invented the minerals? Do J.Sh created the minerals? No, friends. I didn't created it. It was not man-made, my dear friends. It was naturally occurred. It was not artificial. It was not synthetic. It was not man-made. It was naturally occurred in the surface of the earth and as well as in the earth crust, my dear friend. So now we are going to study about the second point. Second point, it is chemical substances. It was chemical substances. And the third point is, friends, it was rocky substances. We all familiar about rocks, right? Rocks used to be in the larger size and huge size. surface, right? So we find the minerals in the large size only. We find the minerals in huge size, my dear friends, in the earth crust and the surface of the earth. You can see in the slides, right? You can see the cinnabar, asbestos and stellamite. All these are minerals only, my dear friends. All these are minerals only. We find them in large size. So how do we find a mineral, my dear friends? How do we find a mineral? When we dig the earth, we find a mineral, my dear friend. When we mine the earth crust, when we mine the earth surface of the earth, we find the minerals, my dear friend. So this is all about the minerals. This is all about the mineral, friends. Now we are going to the second term of the metallurgy. The second term of the metallurgy is nothing but ore. It is nothing but ore, my dear friends. So before we are going to study about ore, we all should change your mindset, my dear friends. You all should change your mindset. Then only you will understand about the ore. Each and every point which I am going to teach you, which I am going to explain you. So friends, you should think like a business point of view only. Each and every point you should think like a business person only, my dear friends. Then only you will understand about the ore. Then only you understand about the ore. Let's see the definition of the ore, my dear friends. Ore is nothing but the metal, the mineral which gives the pure metal by the following three conditions. What are the three conditions, friends? What are the three conditions? The first condition is nothing but it was low expensive. It should be low expensive. And the second term of the second condition is it should be conveniently. It should be conveniently. And the third important point is it should be profitably. It should be profitably mean. What does it mean by economically, my dear friends? It should be economically, it should be low, my dear friends. We find minerals in impure substances, right? So suppose let us think that this is an impure substances. This is an impure substances. Okay, friends. This is an impure substances. This is an mineral. So from every mineral contains pure metal, my dear friends. Every mineral contains pure metal. So we need to extract the pure metal from these impure substances, right? So the industry used to extract the pure metal from these impure substances. So while they are extracting the pure substances from these impure substances, the industry should spend some money, my dear friends. So that money should be very cheap. That money should be very cheap. The industry should spend low cost to extract the pure metal from the impure substances. Then it is called as commercially. Then it is called as commercially, my dear friend. Now we are going to see about the conveniently. What do you mean by conveniently, friend? Conveniently is nothing but while we are extracting the pure metal from these impure substances, it should be very easy. It should be very easy, my dear friends. The process should be conveniently. It should be easy. If it is very hard, how can we extract, friend? If it is not conveniently, how can we extract? If it is very easy, then only, right, we can extract the pure metal from these impure substances. So it should be very conveniently. Then only this mineral is said to be an ore, my dear friend. And finally it was profitably. We extracted the pure metal. So this, let us assume that this is a pure metal, my dear friends. We extracted the pure metal from the impure substances, right? So we need the pure substances. So let us think that this is 1 kg of aluminum, friends. This is 1 kg of aluminum. The industry extracted 1 kg of aluminum from its respective ore. So here when they sell, so to extract 1 kg of aluminum, the industry spend 100 rupees, my dear friend. The industry spend 100 rupees. But when they sell the same amount of 1 kg of aluminum in the market rate was 200 rupees, my dear friends. So what is the profit? 200 minus 100, my dear friends, we get 100 rupees of profit. So here the industry was getting the profit. Then this mineral is said to be an ore. Then this mineral is said to be an ore, my dear friends. So the mineral which follows these following three conditions, then only the mineral is said to be an ore, my dear friend. Then only this mineral is said to be an ore. So if the mineral does not accept this following three conditions, then this mineral does not becomes ore. Then this mineral does not becomes ore. So to become this ore, it should follow the three conditions. It should follow the three following conditions, my dear friend. So I brought some minerals for you, friend. This is the iron mineral. This is the iron mineral, friend. And if you see here, this is the aluminium. This is the aluminium ore, my dear friends. This is the aluminium ore, and this is the zinc ore. And I brought this for you, my dear friends. I brought this for you. This is the aluminium ore. This is the zinc ore, my dear friends. So this is all about the ore, my dear friends. It's all about the ore. Now we are going to study about the third term of metallurgy. What is the third term of metallurgy, my dear friends? You can see in the slides, right? What is the third term of the metallurgy? You should say it, friends. So when I came before here, I gave an rehearsals in front of my friends. I gave an rehearsals in front of myself. So I also asked the same questions to my friends, my dear friends. So what is the third term of the metallurgy? So my friend replied that. So they said that it was Gangu, okay. This was not Gangu or Ganguly Bhai, okay, friends. This was gang. This was gang. Again, you don't divert your mind to the cinemas or movies, my dear friends. In the movies and in the cinemas, there will be a gang. Is also there is a gang. There will be a villain. Backside of the villain, there will be 4 or 5 group of people, and this people is called as gang. They used to fight, right? This is not that kind of gang, my dear friends. This gang belongs to the metallurgy in the chemistry, my dear friends, in the chemistry. So let us see the definition of the gang, my dear friends. So the definition of the gang is nothing but the presence of impurities on the ore. The presence of impurities on the ore, it's called as gang, my dear friends. What are the impurities, friend? I said sand particles, clay particles, rocky substances, and all these are considered as impurities. All is considered as impurities. Suppose you can see in the slides, right? You can see in the slides all the sand particles, all the impurities, all the dust particles, clay particles are present on the ore. Then it is said to be an ore, my dear friend. Then it is said to be an gang. So we all completed the 3 terms of metallurgy, my dear friend. So now we are going to the interesting topic. It was metallurgy. It was metallurgy. Metallurgy is nothing but it is defined as, the definition of the metallurgy is, it is defined as the process of extraction of pure metal from its respective ore. What, friend? What I said, its respective ore. Why I use the respective ore here is from this aluminium ore I get only the aluminium metal. From this aluminium ore, suppose this is an aluminium ore, my dear friends. From this aluminium ore I get only the aluminium metal. Suppose this is an iron ore. From this iron ore I get only the iron metal, my dear friend. That's the reason I use the respective word. That's the reason I use the respective word. So now we are going to see, let us see, suppose we added the plants in our garden. Suppose I planted a apple tree in my garden, friend. So it gives only apple fruits. It gives only apple fruits. Do it gives mangoes? No, friends, it won't gives mangoes. Why? Because I planted an apple tree, so it gives its respective fruit. It is apple. If I planted a mango tree, do it gives apple fruits? No, friends. Why? Because I planted an apple tree. So this is all about why I use the respective word. So now we are going to see the extraction processes. So there are 3 types of extraction processes, my dear friends. So they are concentration of ore, reduction of ore, and refining of ore, my dear friends. So these are, you can see in the slides, concentration of ore. So what do you mean by concentration of ore? In this class we are going to study only about the concentration of ore, my dear friends. So the concentration of ore is also called as beneficiation. It is also called as dredging, my dear friend. So beneficiation is nothing but, dredging is nothing but, the aim of the concentration of ore is to extract the ores and impurities, my dear friends. What I said here, ores and impurities. I didn't say the pure metal and impurities. I said ores and impurities. The extracting, separating of ores and impurities is the aim of the concentration of ore. So to separate the ores and impurities, friends, so there are 4 processes. There are 4 processes, my dear friends. First process was hydraulic washing, magnetic separation, froth flotation, and leaching. In this class we are going to study about 3 processes, my dear friend: hydraulic washing, magnetic separation, and froth flotation. So let us see one by one. Hydraulic washing, my dear friends. Hydraulic washing. This is the hydraulic washing, my dear friend. This is the hydraulic washing. So I prepared with waste out of best, my dear friend. So this hydraulic washing, it is useful to separate the ore and impurities, my dear friend. So here there has a principle. For every process there has a principle and condition, my dear friend. It is based on the gravity. This process is based on the gravity, my dear friend. Suppose here we should take only the heavy ores. My dear friends. If you take the heavy ores only, this process is applicable. So there are heavy ores means what, friends? The arsenic, chromium, and lead. These all are etc. All these are heavy metals. So here I took the chromium, my dear friends. So all the heavy metals should be placed here, my dear friends. All the heavy metals should be placed here. So all the heavy metals I place it here, friends. You can see in this, right? So this is all the chromium, my dear friends. So what I do here is I should add some water. When the jet speed of water falls on this stuff, all the impurities means what, friend? All the gang means what? Sand particles, soil particles, all the rocky substances, clay particles, dust particles, all used to washed away, all used to move along with the flow of the water, my dear friends. They all clean along with the stream of the water. They all move along with the stream of the water, my dear friends. So here I put the beaker, my dear friends. So we can see at the last of this process, we can see the impurities, right? Here is the beaker. We can see the last of the beakers. Here is the beaker. We can see the impurities, my dear friends. Here we can see at last we can see the ore. My dear friend. So what I do here is look carefully, friend. So I am pouring some water. My dear friends. So you can see, right? You guys can see. Yeah. So all the sand particles, all the impurities are washing away, my dear friends. They all are moving along with the flow of water. They all are moving along with the flow of water. They all are moving along with the stream of the water, my dear friends. All the impurities such as gangue particles, all the sand particles, rocky substances, and all the clay particles, dust particles, they are moving along with the flow of the water. So here I think mostly they all are cleared, my dear friends. You can see here, right? So all these are moving. Here you can see the flow of stream of the water, right? So after this, friends, here, so these are ore, chromium ore, my dear friends. Here what we find is chromium ore. So all these, friends, you can see, right? So this is ore, my dear friends. This is ore, and now we see all the impurities. Now we are going to see all the impurities, my dear friends. If you see here, I am separating the water. My dear friends. So I separated the water, and if you see here, what you can see, myself, what I said, all the impurities will be in this beaker only. All the impurities will be in this beaker only. Let's see, friends. So if you see here, what is this, friends? These all are impurities. You can see the sand particles, you can see the rocky substances, clay particles, all the dust particles, right? So this is called gangue. And if you see here, what is this, friend? This was ore. This was chromium ore, my dear friend. What we did here, we separated the ore and impurities, right? So this is called concentration of ore. How did we separate it, my dear friend? With the help of water. We separated the ores and impurities. So the name was given by hydraulic washing. This is also called as ligation, my dear friends. Now we are going to study about the second process. What is it, friends? So the second process is nothing but magnetic separation. My dear friends. So now we are going to see about the magnetic separation. So this is the magnetic separation, my dear friends. So here I made waste out of best. My dear friends. So if you see here, this is in this process also we have some following conditions. What are the conditions, my dear friends? We should take only the ores which attracts with the magnet, my dear friends. If you see here, the ore should be attract with the magnet, then this process is applicable. And all the impurities, they should not attach to the magnet, my dear friends. So here I took, this is a magnetic roller. My dear friends, and this was not magnetic roller. This was a non-magnetic roller. So these both rollers are connected with a belt. So this belt is called as conveyor belt, my dear friend. So here I should add. So now here I am adding the iron ore. We all know that magnet attracts the irons, right? So here I took the iron ore powder, my dear friend. You can see here, from here I am adding the iron ore powder, right? You can see, right? So right, friends. So from here the iron ore was added. So when I on the motor, this vibrates, my dear friend. This container vibrates and it all falls on the conveyor belt. So you can see. Yes, friends. It was falling, right? You guys can see here. It was falling here and from here also. So it was all falling on the conveyor belt, my dear friends, on the conveyor belt. When I rotate the conveyor belt, my dear friends, all the ore particles attaches to the conveyor belt, and all the impurity particles, they does not attach, my dear friends. If you see here, these both are empty boxes, my dear friends. You can see, right? Empty boxes. This is magnetic and this is non-magnetic. Magnetic means what, friends? All the ore particles falls on the magnetic and all the impurity particles falls on this box, my dear friends. So we can see in the last. My dear friends. So when I rotate this conveyor belt, all the impurities, my dear friends, all these impurities falls in this box, and all the pure metal, all the ore particles falls in this box, my dear friend. So let us see how it works. So if we rotate, my dear friends, this conveyor belt, you can see here, friends, all the rocky substances, all the clay particles are falling here, and all the pure metals, all the ore particles are falling here, my dear friends. So friends, let us come to the conclusion. You can see here, right? What can you see, friends? You can see the sand, you can see the rock substances, right? These all are considered as gangue. These all are considered as impurities, my dear friends. And if you see in this box, you can see all the black color substances, right? So all these black color substances are nothing but they all are iron ores. They all are iron ores, my dear friend. So let us check this process is okay or not. This process is okay or not. So here I am taking the bar magnet, my dear friends. If this bar magnets extract this foil, then this process was applicable. If this attracts this foil, then it is process is applicable, my dear friends. So let us check. Yes friends, it was working, right? You can see here, right? It was working, my dear friends. It was working. So this is all about it was working, my dear friends. This was magnetic separation. With the help of magnet only we separated the ore particles and impurities, right? So this name, the process of name is given as magnetic separation, my dear friends. Now we are going to study about the froth flotation. Now we are going to study about the froth flotation, my dear friends. In the froth flotation, there is also an condition, my dear friend. What is the condition is we need to take only the sulfide ores. We need to take only the sulfide ores, my dear friends. And this is the pedal. This is the pedal, my dear friends. And if you see here, all these are instruments, my dear friends. We should add here. All these are instruments we should add here, my dear friends. So we should add this all substances into this container. So friends, if you see here, this is the container, my dear friends. This is a transparent container. I took the zinc sulfide ore. So you can see in the bottom, right? You can see at the bottom. All these are powder ore. All these are zinc sulfide powder ore, my dear friends. And now I am adding the collector, the froth collectors. Why I am adding the froth collector? So we can take the xanthan oil, pine oil, or we can take any oil. We can take the pine oil or xanthan oil or fatty acid, my dear friends. So this is pine oil, my dear friends. So I am adding the pine oil into the container. You can see, friends, I am adding the pine oil into the container, right? You can see, right? So again, now I am adding the stabilizers, my dear friends. Stabilizers we can take as aniline or cresol. We can add the aniline or cresol, my dear friends, as a stabilizer. Why I am adding the stabilizer here is the froth will form, my dear friend. The froth will form. After some time the froth again goes to its rest of piece. Again it goes to its own position, my dear friend. So it should not go to the bottom. It should not go to the bottom. It should be stay at the top of the container only, my dear friend. So that's the reason I am adding the stabilizers to it. It stabilizes the froth to stay at the top of the container only. It stabilizes the froth to stay at the top of the container only, my dear friends. So we can separate all the ore particles, my dear friends. So here finally I am adding this. All these are stabilizers. So all these are stabilizers, my dear friends. Aniline. I am adding here the aniline, my dear friends. Why? Because it stabilizes the froth. It stabilizes the froth, my dear friends. You can see I am adding everything here, right? So at last I am adding the water, my dear friends. I am adding the water. You can think, why you are seeing like this, friend? Do you think this is a chemical? No, friends, it was not chemical. Okay, this was it was drinking water only. Okay, friends, for your convenience I will drink some water. For your convenience I will drink some water. Yes, friends. Now hope you all okay. Now you can do is. Now I am adding the water to it, my dear friends. Now I am adding the water to it. So when I add the water, my dear friends, when I add the water to it, so you can see when I stir this water, the foam used to form, my dear friends. The froth used to form here, right? So this is the pedal, my dear friends. With this help of the pedal, I am going to stir it. You can see, right? I am going to stir it. You can see the white color froth, right? You can see the white color froth which was forming, my dear friends. So all these are froth. So here I am taking a cloth. This was just cloth, my dear friends, nothing abracadabra. Okay, this was just cloth. Okay, so in this cloth I am separating the froth. In this cloth I am separating the froth, my dear friends, right? I am separating the froth. So here, friends, are you ready? We are going to do a magic show, my dear friends. We are going to do a magic show. We don't have the spoon, right? So this is a magic stick. So abracadabra, abracadabra. In 3 counts we are going to open this, my dear friends. 1, 2, 3. So let us open, my dear friends. You can see here, right? You can see here. What is this, friends? You can see all the white color substances. All these are ore, my dear friends. All these are ores. And if you see here, my dear friends, it is all about the ore particles. Here you can see the all the impure substances. These all are impure, and this white color substances are ore particles. What we did, friend? We separated the ore and impurities, right? So in the hydraulic washing, we separated the ore and impurities. In this all process, we separated everything, my dear friends. We all are using lot of metals in our day-to-day life and in our relevant life. So human beings are depending upon the metals. Human beings and metals both are interlinked to each other, my dear friends. Everywhere we are using metals and metals. So this is all about the metals, my dear friends. So I thank our respected Ajay Kumar sir, teachers and everyone, all the school staffs and principal, RCO sirs, and I thank our respected, our honorable beloved secretary sir and the Gurukulam Society, and I thank our TSAT and everyone, my dear friends. Thank you.